Welcome back, everyone. Moving on to the next question. We have to solve both of these expressions here. So notice, like the previous video, it's the exact same expression. It's just over here we have an equation, and then over here we have an inequality. So starting with the equation, what I'm going to do is I'm going to get this absolute value to be by itself on the left side. So what would happen first is I would bring over this 2. So we'd have 7 minus 2, which is 5. And then what we want to do, we want to divide both sides by 2 over 3. So these would cancel out, and then we'd have 5, this is like 5 over 1, divided by 2 over 3, which is like 5 over 1 times 3 over 2, which would give us 15 over 2. Right? So we would end up with the absolute value of 3x minus 2 equaling 15 over 2, like that. So this and this are the exact same thing. And then once we get to here, we know because of this absolute value, we got to split it up into 2 cases. So we would have, when does positive 3x minus 2 equal 15 over 2? And then when does negative 3x minus 2 equal 15 over 2? If you want, this negative could be on this side as well. I usually just keep it on this expression. So what would happen here is, to isolate for the x, we'd have 3x, bring the negative 2 over. So we'd have like plus 2 on this side, which is like plus 4 over 2. So we would end up with 19 over 2. Divide both sides by 3, x would be 19 over 6, like that. So that's one of the solutions. Then over here, negative 3x plus 2 equals 15 over 2. What I'm going to do, let's actually keep the negative 3x here. This I'll bring over, it'll become a minus 2, so minus 4 over 2. 15 over 2 minus 4 over 2 gives us 11 over 2. Divide both sides by 3, we would end up with, or negative 3 rather, we'd end up with negative 11 over 6. So those are the 2 answers here. And you could check them. You could take this, plug it in here, take this, plug it in here, and this left side should equal 7. Or you could plug it in here, and whatever you get should be positive 15 over 2. One of them will give you positive 15 over 2, this one. And then when you plug in this, you'll get negative 15 over 2. The absolute value of negative 15 over 2 is positive 15 over 2. So that's the equation. Those are the 2 solutions. Now with the inequality, same thing applies. We would bring the 2 over, divide both sides by 2 over 3. So we want to get that absolute value to be by itself on the left side, and we'd end up having this being greater than 15 over 2. So this exact step is the same. It's just now we have an inequality sign right there. Then from here, same thing. We would have those 2 cases. Like that. Here, bring this over, so 19 over 2. Divide both sides by 3. So we'd have x has to be greater than 19 over 6. That would be one of the solutions. And then over here, we'd have negative 3x plus 2 has to be greater than 15 over 2. Usually, if I have a negative, I'll bring it over, but let's keep it consistent as over here. So what we would end up with, when I bring this over, minus 4 over 2, so we'd have 11 over 2. Now, when you're dividing by a negative, and you're dealing with inequalities, you got to make sure you flip that inequality sign like that. Right? That's why I usually like to take this and bring it over so I don't have to worry about that flipping. But if you do divide by a negative or multiply by a negative when you're dealing with inequalities, you always got to flip that sign. So whichever way you do it, you would end up with this over here. And notice that we can't really combine these 2 solutions, because if you show these on a number line, let's say this is 0 here, x being greater than 19 over 6 would be like that. And then x being less than negative 11 over 6. These are wholes here, right? They're not inclusive of those endpoints. It would look like that. Right? Versus the previous one, we were able to combine them because it was greater than the smaller number and less than the larger number. And so the number line would be the shaded in area between the points. Right? But in this case, we can't really combine them. We have to keep them separate like that. Another way you can express this, you could say 19 over 6 to positive infinity, or from negative infinity to negative 11 over 6. Like that. Right? So different formats you can show it in, whether visually with a number line or with an inequality or set notation, whichever one your prof or teacher wants. Right? But nevertheless, these are the solutions to this equation and that inequality.